How can we calculate the volume of this solid? Well, this kind of solid is called a right cylinder. And a right cylinder is any solid where you've got two bases that are in these parallel planes that are separated. And in each of the parallel planes, you have the exact same shape with the exact same cross-sectional area. And then those two areas are connected by lines that are just perpendicular to those areas. That's what's called a right cylinder. So you're familiar with right cylinders that have base shapes like circles, squares, rectangles, etc. And the volume of any right cylinder is the cross-sectional area of the base shape times the height. So calculating the volume of a right cylinder is all about getting the cross-sectional area of the base shape. But this is kind of an oddly shaped area here. So how can we determine the cross-sectional area of the base? Well, if you look closely, this is just a sector. And now that we understand radians, we know that radians simplify the formula for the area of a sector. But we can still find a volume formula for this shape where you input theta in degrees. It's just personal preference. Maybe if you're presenting this to a customer, they're not as familiar with radians, so you might want to give a formula in degrees. Just depends. So let's do this in radians first. What's the area of this sector if theta is in radians? Well, the area of a sector is really simple. You start with the area of the full circle, which as we know is pi r squared, and you're just going to multiply that by, so you have the fraction of a full rotation that the angle is. So a full rotation in radians is 2 pi, and then the angle is just whatever the angle is. So we have a fraction here, some fraction of a full rotation. It's going to be that same fraction of a full area of the circle. Okay, now if we come here and do this in degrees, well, okay, it's the same area of the circle, pi r squared, but now a full rotation is 360 degrees, and then theta is just theta in degrees. We'll do this. This is theta in radians, this is theta in degrees. Okay, now what happens is if you're in radians, the formula simplifies because these pi's cancel, but we don't have that with degrees. There's no canceling. So what we're left with is that the area of the base in radians is 1/2 theta in radians r squared. Here, with degrees, the area of the base is pi over 360 theta in degrees r squared. So you can see this formula is a little bit cleaner. So now to get the volume of the cylinder, we just multiply the area of these bases by the height. So the volume in radian measure is 1/2 h theta r squared. Here in degrees, and there we go. There's the volume of this solid. Okay, now what about this solid? This is just like the solid before, but now it's hollowed out in the center based on a outer radius, which is just the same radius as before, but they're calling that R1, and an inner radius, R2. Okay, so that this video won't go too long, we're just going to calculate this volume with theta input in radians. But as you can see, that's further evidence of how we don't want to do things with degrees because it can be cumbersome and time consuming. Okay, so how would we do this? Well, it's the exact same concept in that we can calculate if this was a full circle, a full cylinder that's just hollowed out, what would that area be? And then multiply that by the fraction of a full rotation that theta is. So how do we, if this was a full, didn't have a missing piece here, if this was just a full like pipe, what would the cross-sectional area be? Well, it's pi times r outer squared minus r inner squared. And you can think about that comes from, so you do the area of the entire circle minus, then you subtract out the area of the inner circle. And then you can factor out the pi, and there you go. Okay, so we want to multiply, this is the area of, if this wasn't missing a piece here, we just want to multiply this by the fraction of the full rotation that theta is. That's the area of the base. So the pi's cancel, and we're left with, so 1/2 theta r1 squared minus r2 squared. Okay, there's the area of the base just multiplied by the height. And there you go. And this theta is in radians.